Hello, and welcome to the Chem 1201 Homework Guide, where today we'll be going over this problem and giving you a step-by-step guide on how to complete it. Let's read the question first. The question is, a 75 milliliter solution of hydrogen chloride with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity calcium hydroxide. What was the concentration of hydrogen chloride in the original solution? And what you want to understand about this question is, it is very similar to a lot of other questions we have done before. This time, however, we are not given the grams of the granular amount of what we're trying to find. Instead, we are given the volume and the concentration of another compound that is mixed together with what we're trying to find. Let's look at the problem in a broader perspective. Okay. Here you can see the balance equation. It is important to note that anything that is not, unless stated otherwise, everything in this equation is aqueous. And the first thing you might want to do, or at least that I would do, is I would most certainly convert the milliliters to liters. So in this case, this 75 milliliters will become 0.75 hundredths liters. And then this 27.3 milliliters will become 0.0273 liters. Now that we're out of the way, let's move on. Next, what we want to do, after drawing the balance equation, of course, is draw a picture. Let's look at the original solution. Here we can see the original solution of hydrogen chloride with one hydrogen ion and one chloride ion, denoted by these symbols right here. Based on what the equation gave us, we know that there is a 75 milliliter volume in this, let's say, box. But however, we do not know the concentration. That is unknown to us. What we do know, however, is the volume concentration of this box of calcium hydroxide. So how do we find the molarity of this when all we have is the volume? Well, it's simple. We use this problem to get the molarity, the moles of this, and we can solve it later. First of all, how do we find moles from concentration and volume? Well, quite simply, it is concentration times volume that equals moles. So using the information we have, that's 0.157 molarity times 0.0273 liters to give us this number. With this number, we can now move on to the next step. Unlike our granular problems where we have to use formula mass, our moles have already been found, because as you know, the grams divided by the formula mass is the moles of that said compound or ion. So now that we have that, we can move on. So what we need to do now is multiply the moles of HCl, or CaOH2, my bad, by the stoichiometry, the balanced equation. So if we look back, we'll see that we have 2 moles of HCl and 1 mole of of calcium hydroxide. So doing the math, we'll take the number we got from here and multiply it by 2. These will cancel out, respectively, leaving us with this number. However, we are not done yet, because if you look back, you remember that concentration is moles divided by the total volume. So what we have to do is divide by the original volume, as stated up here, original solution. So when we divide that together, we get this number, which is our answer. Now, I'm going to go over a few common mistakes that could possibly arise in students. The first of being forgetting to convert your numbers. While this might seem like a trivial thing and quite obvious, do know that it does happen and you should be wary. The next thing you should worry about is your balance equation. Make sure you always write out the entire equation, even if the products are not used in the equation. That way, you can get a better understanding of what numbers you need to use and make sure that you don't put the wrong thing. And the final tip I will give you is make sure that you put what you're trying to find at the top of your division equation down here. You never want to change them up because then that will cancel out your division problem or your canceling problem. With that being said, I hope you have a wonderful day and I'll see you next time.